All right, hi folks, this is Larry Mussolino recording a video for week 2, and I wanted to go over a few examples of solving what are called systems of equations. And a system of equation is really when you have two equations to solve. I'll call it equation A and equation B. So there's two equations to be solved, and notice there's also two letters, x and y. I'll call these two variables. So what we need to do here is we need to find a value for x and find a value for y. These two numbers that you come up with, x and y, have to be valid solutions to both equations. It's not good enough that the xy pair is a solution to just one equation. The xy pair has to work for both equations. That's what we mean when we say a solution. So how do you come up with this xy pair of numbers that you're looking for? Well, there's three ways you can do it. You can go to, let's say, desmos.com, and type in each one of these equations. And when you do that, you're looking for where do the two lines intersect. That's the solution you're after. Let me just give you an example here. Let's say you graphed one line and it went uphill like this. And then you graph the second equation, the second line, and it went downhill like this. And let's say this point where they intersected is x equals 7 and y equal 4, let's say. So this point is 7 comma 4. Well, the x value is 7, the y value is 4. That's the solution you're after. All right, but there's other ways to solve these systems also. One other way is called substitution. Let's do an example like that. What substitution means is look for an equation where you can easily get x or y by itself on one side. Let me come here to equation B. I'm noticing I can easily get equation B solved for x, meaning get x by itself. The way I'm going to do that is I'm going to add 3y to both sides of this equation. If I do that, I get x equals -1 plus 3y. Now I go back to equation A, which was 2x plus y equal 5. And because x is equal to this box here, -1 plus 3y, x is equal to that quantity, I could substitute for this x and replace it with -1 plus 3y. That's why we call it substitution, because you're substituting for x with this expression we got from equation B. Well, now this equation is just an equation that has y in it. Let me multiply this 2 inside the parenthesis. -2 plus 6y plus y equals 5. I'm going to put a 1 in front of that y to make it a little easier there. Well, here's 6y plus 1y. That's 7y. Let me write it up here. -2 plus 7y equals 5. Well, I'm going to add 2 to both sides because I want to get the numbers all over together on the right-hand side. 7y equals 7. I want to get y by itself. Right now, y is being multiplied by 7. If I want to get y by itself, I could divide both sides by 7. Y equals 1. So that's part of the answer, y equals 1. But we also need to find x. What I could do is go back to either equation. I could either go back to equation A or equation B. Well, I'm going to use this version of equation B that says x equals -1 plus 3y. But we now know that y is 1. So I'm going to replace this y with a 1. So x equals -1 plus 3 times 1. Well, order of operation says I've got to do this multiplication first. 3 times 1 is 3. -1 plus 3 is a 2. So x equals 2. So that's the solution. X equal 2, y equal 1. Sometimes you write it as an ordered pair with the x value first, the y value second. So I could write this as 2 comma 1 for my answer here. So either writing it this way is okay or writing it this way is okay also. So this is the method called substitution. And it's good to use this method when it's easy to solve one equation for either x or y. In our example, looking at our equation b, it was easy to solve that equation for x. All right, that's the substitution method. What about the elimination method? How does that work? Let me go to another example here. What we're going to try to do for elimination is we're going to add the two equations vertically. What I mean by that is we're going to add the x's together straight down. We're going to add the y's straight down. And we're going to add these numbers straight down. But now I'm not going to do that yet. What I'm trying to do here is I want to get the numbers in front of either x or y to be opposites of each other. Because what I want to happen is when I add the equation straight down, I want either the x or y's to cancel out. For example, if I had a 7x on the first equation, I'd want a negative 7x for the second equation. So when I add them, they would cancel out. Or maybe I want a 4y on top and a negative 4y on the bottom, so that when I add them, they cancel out. So that's what I'm looking for. Well, how about if I take equation B and I'm going to multiply it by 4? So let me take this equation and I'm going to multiply by 4. Why am I multiplying by 4? Well, I'm noticing up on top here, it's a positive 4y. So I want down here to be a negative 4y. So I want this to be a negative 4y because that would cancel out with the positive 4y in the first equation. So that means I want equation B to be multiplied by 4. So let me do it. Now, what I got to be careful about is I need to multiply every part. Let me write it down here to make it a little easier to see. Here's equation B. I've got to multiply every part of this equation by 4. So I've got to multiply the 2x by 4. I have to multiply the y by 4, and I have to multiply the 6 by 4. When I do that, this is going to be 8x minus 4y equals 24. How about equation A? Well, equation A, I'm just going to copy over. I'm not going to do anything but just copy that over. So that's 3x plus 4y equals 20. Now, I'm going to add these equations straight down. So add these equations straight down. That means add the x's together. 3x plus 8x is 11x. How about the y's? Well, I have a positive 4y, negative 4y. If you add those, they cancel out. Remember, that was our goal. And for the numbers, 20 plus 24, that's 44. Now I can solve this equation for x. I'm going to divide both sides by 11. So x equals 4. Well, that's part of the answer, but I still want to figure out y. So I can either use equation A or equation B. That's up to me. I'll use equation A here. It doesn't matter. You can use either equation. Equation A was 3x plus 4y equals 20, but we now know x is 4. So I'm going to replace this x with a 4. 3 times 4 is 12. 12 plus 4y equals 20. Subtract 12 from both sides. 4y equals 8. Last step, divide both sides by 4. It looks like y equals 2. So here's my answer. X equals 4, y equals 2. You can write that as an ordered pair 4, 2. So the idea here for elimination is you want to eliminate either the x or the y when you add the equation straight down vertically. It's up to you. You can cancel out either the x or the y, whatever you think is easiest. The way you can do that is try to get the numbers in front of the y. Here we used y. Try to get the numbers in front of the y to be opposites of each other. So because we had a plus 4 on top, in the first equation, we wanted a negative 4y on the bottom equation. All right. Now, one other comment is when you're solving, a system of equations like this, there's really three possible outcomes of what can happen. You can either end up with an 1xy solution. Those are the examples we just did a minute ago. But there can also be a scenario where there's no solution or where there's an infinite number of solutions. So how do you know if there's no solution? How do you know if there's an infinite number of solutions? Well, here's what's going to happen. If there's no solution, when you solve the system, both the x's and y's cancel out, and you're left with a false equation. False equation might be something like 0 equals 7 or 9 equals -2. These are false equations. When that happens, there's no solution. How about infinite number of solutions? Well, for that, again, the x's and y's will both cancel out, and you're left with a true equation. When I say a true equation, I mean an equation like 5 equals 5 or 21 equals 21. These are true equations. That would signal you that there's an infinite number of solutions. All right, the other way you'll know this is if you graph the equations, and the equations are graphed as parallel lines, that means no solution. If the two lines overlap each other, let me try to draw one blue line and one red line. I'm going to try to draw it so they're overlapping each other like this. Imagine these two lines are really sitting on top of each other, overlapping. That would mean infinite number of solutions. All right, let's do a couple of examples to kind of see this play out. Let's do this example here that says solve this system. Let me write these equations on top of one another. 2x minus 3y equals 4, and 6x minus 9y equals 36. Let me call this equation A. I'll call this equation B. All right, I'm going to use the elimination method here. We can either eliminate x or y. That's up to you. Let's eliminate x. Well, I'm noticing the bottom equation has a 6x. What I'd like to do is I'd like to get this top equation here to be a negative 6x. So we want this to be a negative 6x, because that would cancel out the positive 6x in equation B. How do you convert 2x to negative 6x? Well, I'm going to multiply equation A by 3. Excuse me, by negative 3. That will get me the negative 6x in equation A that I want. So let's do it. So here's the equation we're starting with. 2x minus 3y equals 4. But I got to multiply everything by negative 3. So let me put a negative 3 here, a negative 3 here, and a negative 3 here. All right, well, this is going to be negative 6x. Now here I'm really multiplying a negative 3 times a negative 3. That's going to be a positive 9y there, and negative 12 on the right-hand side. So this is the new equation A. All right, let me just copy equation B directly underneath it. Equation B was 6x minus 9y equals 36. Now I'm going to add these equations straight down. Well, kind of a strange thing happens. Do you notice that the x's cancel out? But also the y's cancel out as well. So really everything on the left-hand side here cancels. That leaves me a 0 on the left-hand side. On the right-hand side, I have a negative 12 plus 36. That's 24. So I have 0 equals 24. Well, this is a false equation. When that happens, this is telling you there's no solution to this system. That means there's no value of x, no value of y that would work in both of these equations. Okay, so if you solve the system and both the x's and y's cancel out and you're left with a false equation like we just had, that indicates no solution. If you were to graph these two lines, you would notice they would be parallel lines. Parallel means they will never intersect. And remember, the intersection point is the solution. But if they never intersect, that would mean there's not going to be a solution. All right, let me do one more example down here. All right, so we're going to solve this system. How about here? Let's eliminate y. So let's try to eliminate y on this one. You could eliminate x. That's totally up to you. Let's eliminate y. Well, I'm noticing there's a negative 4y on the bottom. That means I want this top equation to be a positive 4y. That means I'm going to multiply equation A by negative 2. So let me do it. So we got 3x minus 2y equals 4. I have to multiply every part of this equation by negative 2. All right, let's see here. This is going to be negative 6x. Here we got a negative 2 times a negative 2. That's going to be plus 4y and negative 8 on the right-hand side. Let me just copy equation B as is. So that's 6x minus 4y equals 8. Well, I'm going to add these equations straight down. The x's cancel out. The y's cancel out. That leaves me a 0 on the left side. On the right side, I have negative 8 plus 8. Well, that's 0. 0 equals 0. That's a true equation. When you end up with a true equation like this, it's telling you there's an infinite number of solutions. And so this is the answer for this problem here. And if you were to graph these two equations, you would notice that these two equations really end up graphing as the same line. So the two lines are overlapping each other here. So if you were to graph, you would see the two lines overlap one another. All right, hope this is helpful as you're working in week 2 of the course. Thanks, everyone.